Swayam Prabha. Digital India. Educated India.
Welcome back to the series of manufacturing automation lectures. So, let me remind you, in our last session we have discussed some part placing mechanisms, we have discussed some escapements. So, we said that there are some natural escapements that is activated by the parts and the work carriers, but actual escapements activate the parts and the work carrier and facilitate the parts to go to the assembly machine one by one. We have also discussed that the parts, when they are going to the assembly or the work carrier, the assembly machine, then the part may be displaced, and therefore, only gravity feed track along with the escapement may not be enough for the part to position in a right way or to keep the position intact. In that case, what is used is the part placing mechanisms, and we have seen different mechanisms of the part placing mechanisms, which are basically the robot arms, manipulators, etc., and they may take up the part from the feeder and they will place it to the work carrier, so that the work carrier could carry the parts to the machine, to the assembly machine. Next, what we said is that there are certain changes in the design that can be made, so that the automatic assembly can be efficiently made, and a huge amount of spending can be saved by these designs. Let us see some of them. So, we said that the design for automatic assembly is basically, there are of two aspects there. One is the product design for ease of assembly. I gave you some examples of chamfers, for example, or so that the two parts cannot be stacked together, because you should understand that when the parts are fed from the ball feeder, inside the ball feeder the parts are stacked, many of those together. So, they may entangle with each other, they may stick to one another, stacked in between, and so on. And the design of parts for feeding and orientation. We will take some examples how the design can be changed, so that it can be easily assembled or it can be easily fed and oriented. Product design for ease of assembly. First point is the reduce the number of different parts to a minimum. This just in the previous session I discussed it. Can be achieved by employing one of the new processes that enable complex parts to be produced, for example, precision die casting or new forming processes. Let me explain it to you. If a complex part can be produced, that will reduce the number of assembly processes drastically. That means that 2 or 3 parts, they are actually designed and made together, okay, by casting process or by metal forming process, and that way we are reducing the number of different parts. Second point is introduction of guides and tapers which directly facilitate assembly. These examples we will see later, that how the implementation of the taper or a chamfer could facilitate the assembly. Assembly in sandwich or layer fashion, in the sense that when the assembly is made, it should be made preferably on a base plate, and then parts should be stacked one on another, on top of another, and access to the sub assembly or the assembly should be from one direction as far as possible. That is what we mean, that the assembly in the sandwich or layer fashion. We will see the example. Assembly on a base, as I said. So, here are some of the examples. These examples are quite self-explanatory. For example, the product design for ease of assembly, introduction of guides and tapers which directly facilitate assembly. Let us take an example. suppose we have a part like this, all right, and a spring has to be assembled, a spring has to go in. So, part placing mechanism will take the spring and put it here. Now, because of this edge, all right, the spring actually may not go up to the end and it may get stuck here, okay, because of the design in this part. But this design can be changed by making a chamfer here, that is one thing, and a chamfer or tapering in this case. So, that even if it happens like this, as it is shown in the first diagram, the taper that will guide the spring to the desired position, and with this chamfer and this taper, the spring will never be in this position actually, because in this case here it is also lying on that edge of this part, all right. In this case, if there is a chamfer, so this will also guide the spring to come to the desired location. There are different kind of threaded points. For example, here there is a rolled thread point. This is taken from, I mean, it can be obtained from the cold roll, all right. This is the headed point, and here we have a chamfer. The difference between this is that this is cold rolled and this is with a chamfer, all right. Now, this also has a chamfer. Now, here this is a dog point, this point is called the dog point, here there is a cone point and here there is a oval point, all right. So, these different types of screws, now they mostly are used in practice, like for example, if there is no chamfer cold rolled, so they are very cheap. So, therefore, they can be easily used, but when these are used in the automatic assembly, to facilitate the automatic assembly, basically the cone point or the oval points, this should be used, because the cone point and the oval point, this will facilitate the parts, this will to go to the threaded adjoining part, for example. So, dog point, for example, this also can guide the screw, okay, or the threaded part inside the threaded hole. Here there are some examples. For example, this insertion is difficult because it is blind here, and sometimes there is a small hole made so that the insertion can be facilitated, all right, or there could be a flat here. This is the hole in the pin or flat in the pin, okay. So, this will facilitate the assembly. Here is an example of a plug, which you understand this is a simple 3 pin plug. When we said assembly in sandwich or layer position, this is exactly what we mean, that this is a base for the plug, and to the base the parts are coming from one direction, preferably from the top. See, this is the ground pin, this is the fuse clip coming to the ground pin, this is the fuse when these two clips are made. So, then the fuse can be put in. This is the neutral pin, all right. So, neutral pin, live pin, ground pin, they are placed here, then the cover can come. So, all are coming from the top. See, the access to the parts, to the assembly is from one direction, preferably as far as possible. When everything goes in, after the cord grip is made with the screws will be coming from the opposite direction, and the main screw to fix this base to the cover, this will also come from here. So, as far as possible, most of them will be coming from top, okay, sandwich or layer fashion. Only thing is that cord grip screws and the main screw, these have to come from the opposite direction. Product design for ease of assembly, we are continuing. It is always necessary in automatic assembly to have a base part on which the assembly can be built. This base part must have features that make it suitable for quick and accurate location on the work area. Let us take an example of this. For example, this is a base, all right. Now, when this base, this is a work carrier. So, when this work carrier, it will be coming on this, on the work carrier. So, this part as a base part coming on to the work carrier, this will be unstable in here, because any force which you impart at this point, this will actually rotate the part, because they will be touching these two edges. As you understand that without this ledge or without this alteration in the base part, this base part will be unstably located on the work carrier, because any force which is imparted here, this will actually rotate on the edges. So, there is a small change in the base part that we are doing here, small feature that has been introduced. This is making the quick and accurate location of the work carrier on the work carrier possible. So, once again, this is the base part, this has to come on the work carrier, and for quick location and accurate location of the base part on the work carrier, there should be some specific feature. So, without that feature having here, this base part on the work carrier may not be located easily or accurately. That is what we are saying. Now, sometimes the work carrier base part is here. So, they sit on the work carrier with a dual pin. Okay. So, these are the pins, and these pins go into these holes, so that the base part can be quickly located here. Location of the base part in the horizontal plane is often achieved by dowel pins mounted in the work carrier. So, these are the dowel pins, and they are, as I said, they can come in. So, in that case what is happening, that base part can be located with respect to these holes as well, and that is very important, because some screws, something, some rivet, something goes in this. So, they have to be located properly with respect to the axis in this direction, and they can be done by putting the base part on the dowel pin. These are other examples. Here some of the examples given with the help of self explanatory diagrams, how the parts can be designed for feeding and orientation and orienting. For example, this kind of parts, glass type, all right, with a cone, or a part which is like this, there is a straight slot here. Now, here there is open ended spring. So, here you can see the change in the design, the small feature that can be introduced, so that these parts can be fed or oriented in a proper way. For example, these parts may nest, one glass may go into another and they can stack, and it will be very difficult for the parts to go out on its own. So, this feature is made, that is the rib in part will stop the nesting. Now, one thing we have to keep in mind, that these are the small features which should be non-functional, in the sense that these features which we are introducing, either the feature that we said here, all right, in the base plate, or the feature for example here, these features should not disturb the operation of the part. So, they will be non-functional. For example, here there is a straight slot. So, another of this kind of a part which are there stacked in the bowl feeder, they can be actually entangled. So, if we have a crank slot here instead of having this straight slot, in this case two of those or few of them, they cannot entangle between each other. So, this is the advantage of changing the small feature in the design. For example, if we have the open ended spring, so another spring can come in easily and they can get entangled and they will clog the exit of the ball feeder. Now, here we can have a close ended spring instead of the open ended spring, all right, and in this case the springs will not be entangled with each other. Here there is an example of an open spring lock washer, and that can be closed, for example. Now, here you may one may ask that if this is the open spring lock washer, then if we close it, then this spring lock washer functioning will be affected. This will not, because still we have, you can see that this is not exactly flat, but it will still have the springy action, so that it can still work as a spring lock washer. The only thing is that it will not be open here, so that they are not entangled with each other. Look at this example for here. This is asymmetrical. Okay. Here there is a stud. So, this stud has one end with a thread which is smaller than the thread at the other end. All right. In this case, what will happen, if for example, this is the ideal orientation that we want, but if the part is coming in the other orientation, there will be no feature here, so that it can be reoriented. Okay. But to avoid that problem, suppose we are actually increasing the length of this thread by this much, so that it could be equal to the length of the thread made at the other side. In that case, whether the part comes in this position or that other position, it will not be matter. Now, one question that we should discuss here, that when we are increasing the length of this thread to this length, in that case we are incurring some cost, of course, because this we require this much length. So, it was designed like this, and now you are changing the design by increasing the length of the thread, for which we have to incur some cost, but it can be economically justified, because otherwise what will happen, some reorienting device has to be created for this to reorient the part if it is not coming in the right orientation. So, economically it has to be properly justified, that if we can make the change in the design in such a way, how much cost will be incurred, and whether it can be justified by eliminating the reorienting device for this kind of parts. Here there is a part shown which actually is very difficult to orient because of this groove here. So, this groove, since it is made not completely, okay, let us say halfway or something, this is the design. So, this feature makes it very difficult to make them to orient the parts. Suppose if we make it like this, all right, in this case this functioning should not be affected, that is one thing, all right. So, we say that any feature, I repeat once again, that any feature that we are introducing, this will be non-functional, in the sense that it should not disturb the functioning of that particular part. So, if we are extending that, in that case it will look like this position, they look like this diagram, and here it will be very easy to orient, because this orienting device can base on this surface, whereas here there is no base, because it is not open, all right, meaning that there could be some thing, some part here based on which this part can be transmitted, all right, but here it is not possible because it is closed, as you understand that. So, this feature, by extending this feature in the design, we are not disturbing the functioning of the part, but we are facilitating the parts to get reoriented. These are the ideas of this kind of changes in the design. Look at these parts, for example. These examples are given for parts to feed the parts and orient the parts in a better way, meaning that these changes in the design which are shown here, they will make the feeding and the orienting easier. Let us see this design. This is a disc with a center hole and two holes on the sides. Now, this disc is very difficult to orient with respect to these small holes, because there is no surface here to grab, okay, for the gripping. So, in case we change the design in this way, we are making the flat here, okay, flat here and flat here. In this case, this flat can be taken as a base for orienting this part with respect to these two holes. Otherwise, what will happen, this disc may be gripped in this way or this way or this way. So, there is no way for orienting the part with respect to these two holes, as you understand. Look at this part, for example. If we change the part design in this way, so that there is a hook kind of a thing introduced here in the design, in that case this part can be transmitted, this part can be fed to the assembly machine when it is hanging on a wire, for example. If this is the case, if for this part, for example, there is no way for the part to be fed in a direction or in the orientation like this. And otherwise what will happen, suppose if we do not introduce this, then this part can come in any orientation, but we have to use the reorienting device, for example, to give this kind of an orientation to the machine, to the assembly machine. Whereas, by making this small change in the design, we are facilitating the part to hang on the wire, and it can actually wire on any kind of a rail, so that it can be transmitted in a proper way. In this design, for example, triangular shape of part makes automatic hole orientation difficult. Now, here is a triangular shape. So, either it can come this way or with this edge or with this edge, then it will be difficult to orient the part with respect to these holes. Whereas, suppose we want the part to come in this orientation as it is given here. If we make a small non-functional change, okay, and make a shoulder, small shoulder like this, it is given here. So, this can be based, this surface can be based to orient the part, triangular part, with respect to these holes, for example. So, as you understand that these small changes, here there is a small flat, here there is a kind of a hook here, here there is a small shoulder, they will not change the functioning ability of these parts, but they will, these changes will actually facilitate the parts to feed and orient, for the feeding and the orientation. Well, next let us see what is a precedence diagram and what way it helps us in the automatic assembly. Take an example of this plug assembly that we have seen here earlier. So, here what we said is that two things. One is that it has to be assembled on a base plate, this is the base, and all the other parts should be coming in a sandwich manner or a layer manner from top, basically preferably, and in one direction. It should not come from different directions. Okay. What is the logic behind this? If we are having that from one direction, in that case, first of all it is from the top, so that we can use the gravity, okay. And otherwise what we have to do is we have to use some kind of assistance for the part to flow, because if it is horizontal feed track, as you have seen, in the horizontal position of the horizontal feed track, it will be very difficult for the parts to move to the workstation until unless there are other parts pushing on the top of this, okay, above these parts. So, vertical delivery feed tracks will always be advantageous, because there is a gravity which is working. So, that is one reason why we should take the parts from the top, and different direction will give you the positioning of the bowl feeder and the feed track in different directions. So, the space cannot be utilized properly. So, because of these two reasons, we are saying that assembly should be in a sandwich manner, and preferably the part should be coming from one direction and preferably from the top. Now, the precedence diagram as it is shown here, I will explain it to you what is it. This tells us, precedence diagram tells us the ways, the number of ways an assembly can be made. To give you that example, take this very simple assembly. This assembly is simple because there are only few parts, but as you understand that production machines or production assemblies, they can have thousands or 10,000s of parts, okay. And the way to make the assembly, the order of assembly, this is very important, because in that case the time taken for the assembly will be minimized. So, precedence diagram exactly tells us how many ways we can make that assembly. So, in this case, for example, we say that we have a base. After that, next we will mount the ground pin and the live pin. After that, we will make the fuse clip. After that, we will make the screws then the fuse on top, then the neutral pin, then this screw, then the cord grip, and from here the cord grip screws, then the cover and the screws. So, this is the sequence of assembly that you can make. However, in this sequence we can have some alteration. So, what are those alterations that could be done? It is shown by the precedence diagram that we will discuss in the next discussion. Thank you very much.